In a groundbreaking discovery, physicists have once again confirmed the genius of Albert Einstein, this time by detecting a pair of elusive second-generation black holes. But what does this mean, and why is it so significant? The mystery of merging black holes. Physicists have identified two intriguing pairs of black holes, each with a unique story to tell. These pairs, observed through the ripples of space-time known as gravitational waves, provide compelling evidence for a rare phenomenon. The larger black hole in each pair is believed to be a veteran of a previous collision, a second-generation black hole born from the merger of its predecessors. This revelation was published in the Astrophysical Journal Letters on October 28, 2024. Back-to-back discoveries. The study focused on two recent mergers, occurring within a month of each other. By analyzing the gravitational wave signatures, researchers determined the masses, rotations, and distances of these enigmatic black holes. The first event, GW2-41011, witnessed a collision between black holes with masses 6 and 20 times that of our Sun, located approximately 700 million light-years away. Remarkably, the larger black hole was one of the fastest spinning ever recorded. But here's where it gets even more fascinating. The second merger, GW2-41110, involved black holes with masses 8 and 17 times that of the Sun at a staggering distance of 2.4 billion light-years. And the larger black hole was spinning in the opposite direction of its orbit, a behavior never observed before. Unveiling the universe's secrets. These mergers offer a treasure trove of insights. The larger black holes in both events were nearly double the size of their smaller counterparts, and their unusual spinning patterns stood out among the hundreds of other mergers detected through gravitational waves since LIGO's historic first detection in 2015. Scientists propose that these larger black holes were likely formed in hierarchical mergers, a process occurring in dense environments like star clusters. It's an exciting revelation, said Jess McIver, a study co-author and astrophysicist. These mergers suggest the existence of incredibly dense regions in the universe, where dead stars are forced together. Furthermore, these findings validate Einstein's physics laws, with GW2-41011's gravitational wave signature aligning perfectly with Einstein's and mathematician Roy Kerr's theories about rotating black holes. And this is the part most people miss. These discoveries aren't just about black holes. They're helping scientists understand the fundamental building blocks of the universe, the elementary particles. So what do you think? Are these findings a testament to Einstein's brilliance, or is there more to uncover? Share your thoughts in the comments below.